I'm
confused. That's...
You might not see me because I'm bringing that up. Group quiz.
But that's how I am lately. Confused about everything.
Well, I'm sure that there's got to be something that's different. We can read it when we get to that point and see. Yeah, why won't it work?
Spirit!
Okay, so are you on your quiz then?
Yeah, I gotta plug in my tablet so it doesn't die on me. There we go. Okay.
I'm not doing mine with Excel since I already just watched it all. I put detailed notes. I'll do it later, but I can't get Excel to work unless I bring up SPSS, and it would have been easier to just buy it probably, but like at this point we're about over this class, so okay. So this messed me up. I tried, like you, and I haven't done it with the new. I didn't do the definitions, so I didn't get the first one correct.
Okay.
So that one says, in an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. So why this was a chi-squared test, he said, it was because it's comparing educational level in the high school, undergraduate degree, master's degree, doctoral degree.
So you had to...
Is this distracting at all?
Your children now, and I have to do my husband.
Yeah, but you're not distracting your mom during homework. You know better.
Yeah, because when the definition, it talks about the degrees or classes in a college.
Are you kidding me? I think I'm just gonna scream. That's what I'm gonna. It's my sister, but I'm not answering.
You'll just have to call back.
Okay, so I wrote down two things. He said independent and categorical data meant it's a chi-square.
Exactly. That's the definition.
Okay. So I wrote that down, and also what else did, oh, and then he said it was more than two proportions because it was the high school undergraduate degree, and that's why it's not just a two proportions test. I did write that also.
Okay.
Oh, are you kidding me? They can't get me on the normal phone, so then they call me on my cell phone. Oh, okay. So 3 is, you want to read?
Yeah, I can read number 3. A human resources manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger and 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis?
Okay, so this one confused me a little bit because
go to bed. Okay, go. That one was in our practice. That's when we went over in our practice exam.
Yeah, it is?
Uh-huh. Word for word. That's number 7.
Okay, so this one, so because it's only a singular test of one proportion, because But this says hypothesis and it says nothing about proportion, and that's why it messes me up. Oh, this
He
is
was talking about there's the two groups.
okay. So there's a group that's 40 and younger, and one that's 40 and older.
Yes.
So is that why it's different groups?
Yes.
Okay. See, that might just, to me, I would think that's a one sample test, and it doesn't say anything of proportion, so I feel like that's
But the answer is a test of two proportions.
right. And
The definition is to determine whether the differences between two portions is significant.
okay.
So they're wanting to find out if in each group, if the differences are significant.
Okay. And by the way, I can't see that page 3 that you sent me of your notes.
The page 3. Oh,
It's all blurry, so I can't get it to work. The other page
okay.
I'm able to print, but
Okay, I'll resend that to you.
okay, you're good. So then number 4, a survey is conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. Total of 248 were heavy players. Of these, 152 were male. Want to determine if the proportion of male heavy lottery is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would you do for this test?
So that was on our test too. Do you
Yeah.
remember which one it is?
So, well, it's test of one proportion because I
Mhm.
have an answer in my face. But let's talk about it a second. So it's only, so you're doing a test of,
Okay, so let me read you the definition, see if that helps. Used to assess, my gosh. Used to assess whether a population proportion is significantly different from the hypothesized value.
okay, so what's the hypothesized value would be? So it's measuring one group of men in the hypothesis against another group of men.
Yes.
So we're doing a male that's heavy and against the whole population. It only
I think of this random sample of
the
adults.
whole population, and we're only looking for heavy lottery players.
Yeah.
So it's a test of one proportion, and it says proportion in this one, so I at least know that much. Just figuring it out.
Yeah. Okay, number 5. A student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They wanted to determine if one of the locks is easier to open, which hypothesis test would be most appropriate for the analysis.
So there's some locks.
We have the 2 groups.
So there's the
One lock turns clockwise, one turns counterclockwise. But they only have 25 students to do both of those.
Yeah, so it's a paired samples test.
Yes.
Those ones are easier to figure out. A bank employs 2 appraisers when approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for this study? So there's 2 appraisers, but they're only checking the same amount of stuff. I mean,
They're both doing each of the 6 properties. So one appraiser is doing the 6 properties, then the other appraiser goes and does the same 6 properties.
so it's confidence interval for 2 proportions.
No.
Hmm.
It's
Hold on.
paired.
It is?
Yeah.
Another paired. Why would that one? Because it's using the same information?
Uh-huh. Because remember, the paired data test is
that one-
dependent samples, one group for 2 measurements, and they're related.
Now that one's tricky to me because it's got 2 different appraisers. You'd think there would be different values.
Uh-huh.
In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. So different is the key word,
Uh-huh.
and it's a confidence interval for 2 proportions because
Because they want the difference.
the difference between, it's the same data. So one that's satisfied and one that's not satisfied. Is that what
I
they're
believe
mentioning?
so.
Yeah, satisfaction with career paths was reported. The same data was reported for accounting majors. So that's like 2 different majors
Yeah.
they're comparing. Okay.
Okay, number 8. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study?
A 1 sample confidence interval only because I'm looking at the
Yeah.
T confidence.
Yeah. And somebody asked on there what the difference was.
Oh, right.
And he said that when it's the one sample Z, that it has a standard deviation. If it doesn't, it's T.
T. I wrote
I thought that was really good information. I wrote that down.
too. Okay. Which one of the following best defines the notion of the significance level of a hypothesis test? So that's the 0.05 is like the significance level of a hypothesis test, and we measure against that. It says it's the probability of the type 1 error.
And I think he was saying that we just need to make sure to know those definitions.
I wrote test on the side of mine when he said it. He's like, that's almost word for word on your test. I'm going to go through all of my assignments and stuff where he said that. And I'm gonna write them all down.
Yeah, because I think it's in here too.
Okay, so we're on 10. Which of the following best defines the notion of the p-value of a hypothesis test?
Oh, he said that's totally the definition. It's the probability of observing a sampled statistic more extreme than the one that one actually obtained, assuming the null hypothesis is true.
Yep.
So that's just a pure definition.
Another one too, like other. So this one's the 95% of all 95% confidence intervals actually contain the true mean. I have that definition memorized.
Yes. Not chance.
Right. I will not ever forget that again.
I won't either. Because that when I seen the start of that, I looked at it, I'm like, it's not the last one for sure. Okay, so we've got that one out of the way.
We're down to the other two now.
Okay.
So 11, or you read, go ahead.
Yeah. You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population portion or percentage of people in town who invest in the stock market is P equals 0.30, or 30%. What is the mean of the distribution of the sample proportion? And that's just 0.3, right?
Yeah, because
Yep.
they already gave it to us.
Yeah.
But then it's just on the Excel, that sample proportions. So that one's easy. So they give us the sample number, N is 100. And we put in the 0.3 on there and it gives us the sample amount, which is, do we put 0.30 or just 0.3?
I think it's just 0.3.
Okay, that's what I have on my answers.
That's what I do.
Sometimes I just get mixed up because it's, okay, so 13 is, 0.046.
Yeah.
Okay, so now we're over to 14 on the normal probability outlet. And I remember that okay, so we just, remember that one on the normal probability outlet?
Yes, and I wrote some notes down here. Just trying to find. Oh, right here. We go to on the Excel. It's compute standard deviation for p hat.
What number are we on?
13. Oh no.
Does it tell us what the z-score is on there? So if we know,
Yeah, the z-score.
huh?
The z-score was. Oh, wait a minute.
Do we know we don't know what it is, right? Because I wrote normal probability outlet as what.
Oh, yeah. It's the z-score is negative 1.091.
How do we know that though?
It was on the Excel.
Oh, so we do have to do it on the Excel first?
Yes. So what from 13, when we have the 0.046 in the compute the standard deviation for p hat, we had p equals 0.3, n is 100. The standard deviation of p hat was 0.046, and then
It gave us the z-score?
yes.
And that was,
So then we changed, the p hat, we changed it to 0.25 because that's in question 14. What is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? So we put that in the p hat. It gives us a z-score of negative 1.091.
You remember that one better than me.
I just barely watched it, so
That's why.
it's
I
still
don't
right
remember
there.
him doing that Excel.
So and
Okay.
then you take the z-score and put that into the probability applet
Right.
in the below, negative 1.091, and the area it gives us 0.138, which is the answer for 14.
Okay. Well, I'm gonna write. I wrote myself a note to go over that one again, because unless I see that, can't you just use the David Lane applet, or no? Because you still have to know below.
Yeah, that's the applet he used.
I wrote normal probability applet, so that one's different. So hold on a second.
And we only have 3 weeks after this week.
I know. So we do below 1.96?
Below negative 1.091.
Huh.
So did that give you the 0.137?
Okay. Below, what was it again?
Below negative 1.091.
Oh, okay. Yeah, that's where it got it from.
Okay.
All right. So now we're on
15.
Acupril is meant to control hypertension in clinical trials of Acupril. 2142 subjects were divided into 2 groups. I remember him doing this on the thing, and it was confusing. I mean, he kept changing the numbers on there.
No.
So I was like, oh, but I did write it all down. So actually what we were after is measuring the number of people that experience the dizziness.
Yeah, the margin of error.
In our X2. And then it was the sample in that period, in that group, and then the sample in the other group.
Yeah.
Okay. Anyways, he did that one on there too, and it was, and then it, no, wait, that's the one that's below negative 1.091, isn't it? So
On 15?
Oh, I think I got my notes messed up. Wait, I got different notes, I believe. Hold on. Mine are so messed up. Okay, so I wrote this down, so then we had to do the 95 percentile thing. And what's our answer for 15 is 0.016.
Yep. The margin of error. Yep.
Because that one's on the Excel one too. So input the lower bound.
The lower bound is negative 0.003.
Do we have to put the 0 on the beginning of it?
I do, just to be safe, I guess. And then the upper bound, 0.029.
Okay, we're on 18.
Okay.
Perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different than the proportion of a control group subjects who do. Use a level significance, which are of 0.05. What are the appropriate null and alternative hypotheses? So it's going to be different.
Different. So I remember him saying different, that the null is always equal.
So it's the first one.
It is. So it's equal. The other one has to be not equal.
Because if it's the difference, that's what it is. So that's
Yeah.
18 difference.
Yeah.
Write that word out to my side. Not that it's going to help me on any test.
Sure it will.
Well, I'm going to print this out and then write my notes on top of this.
Yeah, me too.
The value of your test statistic is 1.458. So how did he do? So wait. So this one is the same as this whole group at the very beginning.
Yes.
Very problems with the next 7. So let me see. I didn't write any notes on there.
Okay, so we have.
But the Z-score was the test statistic, and that's the answer for number 19. But it already gave us when we already plugged in all the stuff, correct?
Yes.
From question 15.
Yes.
And we did that on Excel. So we already had all these questions already answered. The p-value of your test is number 20, 0.145. Okay, so I understood that.
And it said that he said, and you could change the 1-tailed or 2-tailed on the Excel, and that would give us 2. And so the 2-tailed, that one is equal and one is not equal, right? Because that was our hype. Is that right?
So
why it would be 2-tailed?
Yeah. So if it asked us that, but we gave ours as a 2-tailed, am I correct?
Yeah, it was a 2-tailed, yes. So I wrote 2-tailed down, but I was trying to remember why it's 2-tailed is because the null hypothesis is equal and the alternative is not equal, right?
Yeah.
Okay.
Okay, so the 0.145 is larger than 0.05.
Yeah.
So we know I failed to reject the HO.
Oh, wait a minute. Failed to reject. Huh? Oh, wait a minute.
No, I failed to reject the HO. Nope, I failed to reject. No, I failed to reject the HO's, the very last one.
Oh, there it is. The first one was like accept, and I'm like, I don't remember him saying accept, anything about accept. And I'm like, oh my gosh.
I remember that.
No, I failed to reject HO. Okay.
Okay, so 22. Calculate survey conducted of 1279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? HO is independent. HA is not independent of age. So that's the one where we have to go and
do all the work in SPSS.
Yes. So that one took a while, but I wrote all of that down.
I did too.
I
did too. Step by step.
No, I'm not going to, because it asks us to do the test statistic. So
the test for 22, the test statistic is 6.0. 579.
I still think it helps to go over it again. Huh?
It does.
But I am going to write better examples of all of the different tests that we do. So do you feel like the test that you went over, the practice exam, was similar to that? I mean, a lot of the same questions?
This group quiz, yes. I think between the group quiz and our and the notes that he gave us for the exam, I think that we should be okay.
I'm not feeling it. I'm not feeling it. Okay, calculate the p-value for this hypothesis test. Where's my answer?
0.087.
I might go on and try doing this tomorrow. Those ones on the SPSS. Just so I remember how to do them better. Should you reject HO or not? So 0.087 is greater than 0.05.
So no, the p-value is greater
than 0.05. My air conditioner is running all day today.
It was supposed to be 95 up here today.
It was over 100 when we got home, and I turned the air off. And I think my house is still at like 80. So hot. We're going to have the hugest bill. We have 2 air conditioners, but they're like on the deathbed. So just wait till I get a job so I can pay the new ones. Oh, don't die on me.
Yeah.
Okay. So let's look at these. What do we conclude based on our results? So what's our results here? The p-value is greater than 0.05.
So, and greater meant that we
failed to reject.
Yes.
Is that correct?
So it's insufficient. So we have to have insufficient evidence
to say that a morning person is independent of age. What question are we on? So it's the last one. Insufficient evidence to say that being a morning or evening person is not independent of age. So they're saying that we don't know for sure if that makes a difference.
Yeah.
In other words. I try to make some sense of what it means. A recent book noted that only 20% of all investment managers outperformed the Dow Jones Industrial Average over a 5-year period. A random sample of 200 managers who graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. Create a 95% confidence interval of P and put the lower bounds and upper bounds rounded to 3 decimal places. So,
and now we did all in the Excel.
Okay.
That's in the one proportion. And the one thing that I remember I wrote down, when we put in each cell, we have the 0.2, which is the
why?
The 20%.
It's the percent of investors.
And then the next number is 200, so that's the random sample.
Yes.
I just wrote the numbers, and then the p-hat, you have to put in equals 50 divided by 200, and then that gives us the number. And I didn't write that number down, but that's how we get the exact number.
I wrote the p-hat's 0.25, but that would not be correct.
It was a big number.
Huh?
The p-hat was a big number when he put it into calculations. The p-hat.
Okay.
And
And the
Excel.
confidence interval 0.95. Okay, I may go back over that one. I hate going over those though, because sometimes they stop. They're such pains.
So that was with the p-hat. Remember to put in the calculation and not dividing the 50 by 200 in your head and then putting the number in. Let the calculations do that. So I just put equals 50 divided by 200.
Can you do it in there?
Yeah. Uh-huh.
Yes.
Yeah, in that cell under the p-hat.
Okay. Okay, so 0.310, and the input, the upper bound 1537.
On number 26?
Wait, hold on. I skipped 26.
Yeah.
Wait a
So
second.
26 should be 0.190.
Where did I get point? Oh, I was doing 27 instead. 0.190.
Yes, and then 27 is 0.310.
Question 28, 1537.
Yes.
So that is because we did that on Excel. Sample size calculation.
Yes. And that one, that's number 28, right? I wrote down the Excel which ones to use so I can try to go back. 28, you would use the sample size.
Right.
So the confidence interval would be 0.95.
Right.
The t-score is 1.960.
Mm-hmm.
The margin of error is 0.02. The p is 0.2. And then the n would be 1537.
Yeah, and it gives us the P, so 0.2 on there.
Yeah. Yeah.
Okay, so that's how we get that answer. Oh, suppose you wish to see if there is confident evidence that graduates of one top 10 business programs perform better than other investment managers. Conduct a hypothesis test. Use a level of significance of 0.05. So we're going to use those same numbers from above, right?
Yes.
We're just going to see what hypothesis test we're going to use. So we're measuring So we're just measuring, well, HO.
So HO.
No, it's the fifth one. I wrote it down.
E.
So P is greater than 0.2, but why is that?
Because the HO is equal.
Right.
But they want to find out if they outperformed. I don't. What did he say?
So we have the P value already, which is 0.2.
Yes.
And we're wanting to know if the P is use the prior estimate. So we're wanting to know if, why are we wanting to know if it's larger though? Suppose
Hold on just a second. I got somebody at the door.
Okay.
Hi. Okay. You want to go through the garage door? Open it and then I'll pay. It's just. Oh, it's great. Did you get that job? Awesome. Cool.
Are you there? Hello? Oh.
Okay. One of my son's friends, his bike's been here. He decided to come get it.
I wondered if my headache was because when I sit in this chair all day, cuts off the circulation from my feet.
Oh, huh?
I went and got a chair to put underneath my feet, see if that helps.
Oh, there you go.
All right, so we're back.
Okay.
I figured out the answer.
Okay.
I will tell you why.
Okay, do it.
Because it says out there, it says performs better than.
Oh, that's right.
So that's greater than the 0.2.
Yes.
And then 30, we know the definition of that is it has to be greater than 10. So that's the definition of the
There we go. That's it.
P. So then on 31, the value of test statistic.
I got to put in 30.
Let me see. I probably wrote that down, maybe. I don't know. I just wrote use Excel information. That's all I wrote. I just got sick of doing it. So is that what? So we're just doing the test statistic on there.
I wrote down on we're on 30, right?
31.
31. Oh, it was 30.
We skipped. Oh, 30 was, remember,
Is A.
greater than 10 definitions, so it's the first one.
And then he says, when he put that in there, he used the conditions and requirements Excel.
For 30?
For 30.
Okay. Okay, 31, it says the value of your test statistic. So,
And that one is the same as the Z-score.
right, but I'm trying to just figure out what information we're using on that one because 1.768 is my answer, and I only wrote use Excel information, but I didn't write it down.
I didn't either. Shoot.
So it must have been pretty simple to figure out, though, because
Yeah, I think we just needed to plug in the numbers.
we have the level of significance,
Yeah.
and we use the do we use the numbers from question 28, or we go clear back to the top?
I think we go clear back to the top.
Okay, so it gives us all those numbers up there.
The next 8 questions. So we started at 26.
And it's a 95% interval, so that answers a lot of questions, just that one test.
Yeah. Because Yeah,
It's on
95.
It's on the Excel.
Yeah.
That one where you plug in all of the numbers and then you get. It is on the Excel because that's what I wrote. So 1.17. I kind of wish I would have wrote Denmark stuff on that. P-value of your test is 32.039. I might go
Which number? 32?
32. I may
32? 0.039.
Okay. I may go back. I've been writing stuff to go back and just review some of it. I still kind of had questions on that one, even though you told me how, because I can't see it on my computer, and I want that one from earlier that I was struggling to understand. Which one was that one?
Was that the SPSS?
I don't know if it's number 14.
Oh, in the practice exam?
Yeah. No, on this one, the group quiz, that one I still not exactly sure. Because mine says the normal probability applet, and then I wasn't sure. Anyways, I think that's the one that I shouldn't have trouble with that one. I'm sure I can figure that one out. All right, let's go to 33 and then.
Okay. Is there sufficient evidence to conclude that graduates from the top 10 business programs perform better than other investment managers?
No.
Better than. Oh.
Yes.
So it's yes, I rejected HO.
I rejected HO. So, because, okay, so the was less than, so that's why we reject the HO. 0.039 was less than 0.05. I always write that and then I can figure it out. If I don't write that on my paper, I can't figure it out in my brain.
Okay.
So it's less than, so it's yes, I reject the HO, which is the first one.
So better than, in 33, when it says there is sufficient evidence to conclude that graduates from the top 10 business programs perform better than other investment managers, that means that we reject it? The better than, is that the clue for us?
No, I don't think that helps us to know that it's rejected. It only matters the p-value against the level of significance.
Okay.
I think there's sufficient does. Oh, it says is there. I don't know.
Oh, yeah.
I don't know. I just know that if it's less than the level of significance, reject it. So that should be our definitions. How come on 32 I wrote it's a one-tailed test? That must have been significant.
I wrote one-tailed too.
So that has something to do with that answer.
Yeah.
So 34.
Gosh, look at that. We've didn't even do it together. We have the same type of notes. We just not read all of that information and just do the answers.
Yes, good plan.
Okay. I'll read 34. Input the lower bound, round your answers to 3 decimal places.
0.282.
Yes.
This one's easy.
Now remember doing it. Then the 35 is 0.293. Okay, and then 36 is input the test. Oh no, input the degrees of freedom.
99-ish.
Yes.
Hey, I thought he told us we could do this 2 different ways. So, but we can do, because we can do it on the normal applet. I remember he said. Because we can put, anyways, I wrote down test value. We change on that one. Because that will trick me up on the test. And I'm pretty sure we had one like that. Remember how it's usually 0
Yes.
on the test value? But this one changes to 0.29. And he didn't say if that's going to be on the test or not, but.
Yeah.
All right, so 37 is a 2-tailed test, and it is negative 2.803. I bet we're just going to fail this test. So rough for us.
We're going to do good on this test. Okay, so the p-value is 0.006.
Okay.
So, and I don't understand why on here is 0.006, and on our other part with it's the same thing is the 0.003.
Well, I bet it's because the information is different. We could read it if we wanted to, but it's that.
It sounds so familiar.
Okay, I'm just looking at it now. So let me read this to you. They test HO, the mean equals 0.295 against the HA. The mean is greater than 2.295 with 0.05. Calculate the test statistic and p-value for this hypothesis test. Assume the requirements are satisfied. So is it the same? No, it's not.
Okay.
So that's why this is different, because one's a 2-tailed and one is a 1-tailed test. So
what are the key words that it's a 2-tailed and what?
Okay, I'm going to tell you, I know the answer to this one without looking at the answer. Because up here, we're looking for equal to or not equal to. And on this sample test that he did, we in number 15, it says that HO is equal to, and then in the H,
the 0.295
greater than, or it's greater than 0.295. That's why.
Okay.
So remember, one's a 2-tailed, the equal to is the 2-tailed. So it is 0.0.
Equal to is a 2-tailed.
So this one answer is 0.006.
Okay.
Because it's a 2-tailed test. Okay.
Okay.
So now we're going to say we have, so the answer to that other one is 0.003 because it's a 1-tailed test.
Okay.
So that is good. Oh.
Then have Dad give you some Tylenol, please. Okay, so 39 is based on the results of this test. What would you conclude?
Was
Is the level of significance of 0.05.
On the weekends that this is.
So it so our value is 0.006. So that is actually less than 0.5.
Stay here and enjoy that.
Don't ask why this one. We have sufficient evidence to say
Yes.
that mean is different than 0.295.
Yes.
My brain just won't comprehend it.
I know. My.
Well, it means it's time to quit.
I
We have to finish
know.
this. There's 45 questions.
We only have 7 more, and we can
Yes.
turn in.
We'll be done.
Done for the whole week,
Oh, why don't you have to meet tomorrow?
except for our test. Well,
Yeah, we have this our test.
tomorrow is when he talks.
Just the chapter final. Okay, good. As long
And
as
not
there's
the
nothing
chapter
stressful,
final.
whatever. As long as there's nothing stressful coming.
Oh no, we're stressed out anyway.
What stresses me is my other 4 classes I have on top of this.
The problem is we're missing a part, Nathan. It's loose because there's only one screw in there.
And my religion teacher gave me he didn't give me a bad grade. He says, Lisa, I'm disappointed in your work this week. He goes, you can do much better than this.
Are you pushing?
Tell them to do your other classes and then you will.
I was like, because he always tells me how awesome I am. And then this week, he said, you didn't do as good a job as you
Are
usually
you
do.
not the beam
No,
down?
I wasn't.
No.
So,
That's not nice.
well, I don't think he's like, you still did a good job, but you just you didn't put your heart into it like you usually do. You're probably right, though.
Burnt out. That's what it's called, huh?
Yeah, it is. Well, plus he gave us that huge PowerPoint. And so he gave us a lot of work last week. So I wasn't very happy about it.
Oh, huh?
There was too much going on. Anyways, okay, so this one, I don't feel like reading it. But this is, we just input the data on this one
Mm-hmm.
because this is a paired sample test of, so we're measuring, define the differences as AM height minus PM height.
Yes.
So we just plug that into the SPSS.
Yes.
Am I correct? It is SPSS?
Yes. Oh, wait a minute. Let me find it.
Just
36. Yes, number 40. Yes. Do you
because
remember the steps on that, or do you want me to tell you?
is that the one where we just put, no, it says what it is and then we just do it. That one's pretty easy. We just do analyze, descriptive,
Nope. Compare means.
compare means and then paired sample test.
Uh-huh.
And then it gives us our answers.
Then you have to do the variable. So you put the heights in the morning first, and the heights in the evening second, and then it computes everything.
Wait, variable, tell me
One.
that again.
Variable 1
Uh-huh.
will be heights in the morning,
Okay.
and then variable 2 is heights in the evening. So that gives you the height, the morning minus evening.
Oh, it is the minus one.
Yes.
Okay, thanks. Okay, so now we know the answers are, I'm just going to write minus on here because that may help me. Maybe. I just don't know anymore. I got ready to quit.
No, we only have 3 weeks. You can do this.
I have 88% in this class.
That's awesome. I have 82.
Well, I'm mad because, it's only because, when he didn't give me that 10 points for our group study thing, then.
He hasn't put that in yet?
No, he did, and it raised my grade back up again.
Oh, there you go.
I'm like, it lowered it clear to 77%. I'm like, well, I just do bad on every one of these tests, so I don't. No matter what I do, I'm hoping that it works for me, though. Extra study. And the fact that he didn't give us any more information for this week helps.
Yes.
But I don't feel I have enough crud, what number are we on? 40?
40.
So I wrote 8.728.
Yep.
And 10.455.
Yes.
And 22.446.
Yes.
Degrees of freedom are 40.
Uh-huh.
And because is this one the Chi test? By the way? No,
No.
this is the paired sample test.
Yeah.
Okay. Da-da-da-da-da.
So 44 is 0.000.
Point. And 45.
45 is based on your results of the test. Is there enough evidence to suggest that the children are taller in the morning than in the evening? And the answer is yes, because we reject the null.
Because 0.000 is less than 0.05. Yes, that's consistent. So the difference is sometimes it says yes because we rejected the null, which I think confuses me. Or it sometimes just says yes, I reject the HO.
Mm-hmm.
They're the same. And I think that just confuses us sometimes.
It confuses me.
So we just have to remember that when we're doing our test. I'm submitting mine because I'm tired of this.
Me too. My head's hurting again.
And then I can,
Or still.
woohoo, woohoo, 42.
42. I got all 43 on mine.
I must have forgot an answer to something.
Which one did you miss?
I'll bet I forgot to mark something. I don't even care at this point.
Which one did you miss?
I don't see it on here. Doesn't say I missed it. Not done yet. There's gotta be. Oh. Oh. I missed question 31. Oh, because I didn't put the 1.768.
No,
That's all right. I got 42.
you said it right.
No, I feel like that. No, what is that on? Oh, well, so you're gonna go to the test or practice tomorrow
Yeah,
at 7. See if he tells us any more.
I think that he, if I remember right,